Hey there, C++ enthusiasts. Welcome back to our problem-solving series. I'm Khomotsaram Peculiar, and today we are delving into the array and strings. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an episode. Today, we're diving into a practical problem, writing a C++ program to calculate the students' average test scores and their grades. And the program reads as thus. Write a program to calculate the students' average test scores and their grades. You may assume the following input data. You are to use three arrays, a one-dimensional array to store the students' names, a parallel two-dimensional array to store test scores, and a parallel one-dimensional array to store grades. Your program must contain at least the following functions: a function to read and store some data into two arrays, a function to calculate the average test scores and the grades, and thirdly, a function to output the results. Have your program also output the class average. Alright, so the task at hand is to write a program that calculates the students' average test scores and their grades. Now, we're given a set of input data including the students' names and their respective test scores. We are told to utilize three arrays. One to store the students' names, another to store the test scores, which is a parallel array, another parallel array to store the grades. Now, let's break down what an array is and what a parallel array is. To just go straight to the part where we code, you can move the time to an array is a data structure that can hold a fixed size sequential collection of elements of the same type. It's like having a bunch of storage compartments where you can store data of the same kind. And now a parallel array is simply multiple arrays that are related in some way. In this case, we have parallel arrays because each element in one array, which is the student's name, corresponds to the element in the other array, the test scores and grades at the same index. Now, to solve our problem, we'll need functions to read and store data into the arrays, to calculate the average test scores and the grades, and output the results. Additionally, we need to calculate the class average. Once we have these functions in place, we can proceed with implementing the program. But before we jump into the code, let's understand some key concepts further. We did say an array is a data structure that stores a collection of elements of the same type in a contiguous memory location. Think of them as a series of boxes lined up next to each other, containing a value. Now, we must note that these boxes carry the same type. Example, all content being either strings or all content being integers. The first element can be a string, another box with a number, and so forth. Now, with regards to a parallel array, we did say it's a set of arrays that store related data in corresponding elements. Now, for this example, we can say if we have an array of students' names and a parallel array of the test scores, what this means that each element in the student's name array corresponds to the test scores in the parallel array. An example could say if you have an array names, which has three elements, then another array age, which has three elements as well, the element in position 2 of age speaks to that of position 2 in names. Now that we understand arrays, let's start coding our program. Let's clear off all that we have on our online compiler. Because we're going to be manipulating data as we'll be calculating the average, let's include the library. Now let's declare the variable that will hold the number of the students which we will be having. We've declared this as a constant because throughout our code problem, this number will change. Suppose we're going to be calculating an array, a list of students that's 10. That's the number of students, and it should not change throughout the code. Also, for the number of tests of the students that we'll be using to calculate the average. We're instructed to create three number of functions. So we're going to firstly build the first one, the function to read and store the data into arrays. And there, we've built the function to read the input data. So basically, how this goes about is, this function will output the statement, enter the student's name. And while we're at that, while this is the first student, the student at 0, the student will enter the student's name, and also it will now enter all the 5 tests for the students. Hence, this loop is found within this loop. And then as the loop now iterates to the second student, the user will be prompted to enter the second student's name and then enter now all the tests for this second student, and so forth until we reach the last number of the student. You see, this loop ends at number of students, just as this test starts from A0 until the last number of the test count, which is number of tests. As we can see from here, the number of tests is 5. Now let's move on to the next function. The function to calculate the average test scores and the grades. This line declares a function named calculate average and grade that takes 2 parameters, a 2-dimensional array of integers scores and an array of characters grades. This function is responsible for calculating the average test scores and corresponding grades for each student. And there we have it. We've created the second function, which was to calculate the average test score and the grades. And over here we were calculating the grades, and on this first loop we were calculating the average. So let's break down how we calculated this. So this loop will start from a 0 until the number of students. We have 10 students. So we start from the first student until the last student. To calculate the average, what you need to do is to calculate the sum of all the tests that the first students got, and then calculate the sum of all the tests that the second students got, and calculate the sum of all the third students test scores sum up to, and so forth. So that's what this code does. It starts with the first student and sums up the test scores, and then moves on to the second student, sums up the test scores, moves on to the third student, sums up the test scores, and once it's done that, it will build the average. And how the average is built is, so this loop will start. We are on the first student. Okay, while we're on this first student, this variable will keep storing for us the sum of the test scores of the current student we are on. While we are still on the first student, their sum is a 0, and then we collect all their test scores, and their sum has added up to another value, and then we get their average. If their average is supposedly a D, they get a D. We move on to the second student, we get their sum, and then build up their average, and then we get their average, and so forth. The statement can be written in a simpler way. Instead of duplicating the sum, we can put the plus sign this side, and it's still the same statement. Moving on to the last function, the function to output our results. And there, we've completed the function that will output our results. And this is how it goes about. It will firstly output a statement. The statement is just our heading to say this is where the students' names will be, this is where their averages will be, and this is where their grades will be. And now for outputting, because the arrays already contain the variables that contain the answers, this is just for outputting. So basically no arithmetic is being done in here, just output. So here, this statement is basically just to make sure that our output of names aligns to our headings. Please check out this video where we delve deeper into the IOmanip library and all the functions found within it. And here, we will output the names, and the names will be moved to the left of this compiler because by default the output is moved to the right so as to align to this heading students, and the respective students' scores will be updated. Sum of scores will be updated over here, and then we get their average. And for outputting their grades, we just have this. Remember, it's already been stored in their respective array. Here it's just to output them. Remember the previous function we just did was to store that. Yeah. Now we've built our 3 functions. Let's go to the drive of the code. And there we have it. We've built our code. So basically all that we're doing here in the main function is the same. Okay, so we've built all the functions that will do whatever that we need the code problem to do. But when do they come to being ran? Because they were just being built and they were not told, hey, come after this, come before this, and this is what you're going to be fed. Right? So this is where that happens. We tell there's the read function first must be read, the calculate average then will be read with the data that came from the read function. And the output results will be read, will rather be called. And obviously these values can't just come in here without having been declared. The main function will wonder what are these values that have been declared here. So we had to declare them over there so that these functions know what they are doing with this. What is this name? Is it a string, an integer? It's being told it's a string of arrays, and this string of arrays works with the number of students that's already been declared from the beginning. And this int score, which is a parallel array, obviously depends on this number of students, this names, and will be. So I did a few modifications here and there. Like you see, I added some semicolons over here. And it looked like I did not complete the naming of this function. And the grades here were not properly spelled. And yeah, just a few of them. Apologies, I noted that my network had a cut while I had continued speaking. And also I've added a few tabs over here. We shall see with the output why I added that. And also just before we run our code problem, I modified this to say 5 number of students and 3 test scores, just for the purpose of our efficiency in running this test of the program. And we see that our blueberries scored a bit of low marks. Let's check the logic we had built for when it's a 70. So a 70 does speak to C. And let's quickly check our code problem. So you should get a C when your marks is greater than a 70. Right? Good. And if it's greater or equals to 60, it should give you a D. So he did get a D. Great. So now we see that our code problem does align to whatever we fed it. There we have it, folks. It's a C++ program to calculate the students' average test scores and their grades using arrays and selection control structures. If you found this video helpful, don't forget to hit that like button and share it with your friends. And if you have any questions or suggestions for future topics, feel free to drop me an email at gg.ntehelang@gmail.com. Thanks for tuning in. And until next time, happy coding.